What comes to your mind when you hear about nuclear power? Maybe high-end weapons of mass destruction such as bombs, or maybe attacks, war, loss of lives. What if I told you that nuclear power has actually played defining roles in every other sector, especially in the country? Talk of medicine, agriculture, education, potentially energy, and ultimately economy. We are literally talking about everything here. To make heads and tails of that will be three teams. One from the Nuclear Power and Energy Agency NUPEA, another from the University of Nairobi, another from Multimedia University of Kenya, all of whom are physically represented here today. The three will endeavor to break down nuclear power in the Kenyan context and in the form of a debate themed Nuclear Power for Sustainable Development. Worth noting, what is about to go down is not your usual debate where we have opposers and proposers seeking to outdo and to outshine each other. It is instead a conversation where every debater is a winner. On to my immediate right is Wilson Kairu, who is a lecturer here at the host university, the University of Nairobi. Next to him is John Birir, a tutorial fellow and assistant lecturer at the Faculty of Engineering, still at UON. He holds a bachelor's in mechanical engineering, a master's in nuclear science, and is currently pursuing a PhD in nuclear science. Next to him is Dr. Wafula Wekesa from the Multimedia University of Kenya, an energy expert, a consultant, and a lecturer. The next to him is Harrison Ngugi, who is the Acting Chief Officer, Strategy and Planning at the Nuclear Power and Energy Agency, NUPEA. And seated right across me is Nduma Arua, the Acting Chief Officer, Nuclear Energy Infrastructure Development, still at the Nuclear Power and Energy Agency. Gentlemen, thank you for making time for us, and welcome to this episode that promises to be intriguing. And welcome as well our viewer. The next 40 to 45 minutes are certainly going to be totally worthwhile. I'd like to ask this question because I know you must be itching to make your case, gentlemen. I'm itching to hear from you as well. Why should we as a country go nuclear? And actually this question is directed to the NUPEA team in as much as the floor is open. Why should we as a country go nuclear, yet there are other sources of electricity? I mean, from where I sit, we just seem to be doing fine in terms of energy sources. Why nuclear? Why now?
Okay, thank you very much. Maybe I go first. When we talk about sources of electricity, and you rightly said in this country, and we talk about energy demand versus energy supply. Demand is what we require, and like you have said, maybe we have what we require as of today and for now. But we also do some kind of futuristic planning. We might be having enough wind, enough Chudamo today, but what about tomorrow and what about the future? We need to plan like we plan in our development. If we want to, we are aspiring to be an economic prosperous nation. Development and consumption of energy go hand in hand. The correlation between energy use and development is one-on-one. Nuclear energy is not coming in to replace geothermal, to replace coal, to replace anything. We shall still have that. What we are looking into is to have a blend, a mixture of energy that's going to supply electricity at least cost. And this energy, we are going to use it to spur our economic development, achieve the dreams that we have encapsulated in Vision 2030, in Sustainable Development Goals, the aspirations that we have put in there. And in the Africa Agenda for 2063, we also have some goals that we want to achieve. Nuclear energy is favored because of its abundance. For instance, when we talk of abundance in terms of supply, we are saying this electricity is available, it is reliable, and to some extent is considered clean source of energy. When we talk to industries or manufacturers, they talk of something they call base load. They want an uninterruptible supply because they want a 24-hour kind of an economy. We don't want to some kind of intermittency when we have enough of sunlight during the day or during some peak seasons of the year, and then we don't have it during other times of the year. We want that kind of stability, that we have security. We can assure our country that in terms of energy supply, you will get the right amount of energy that you need, you will get it at the right price, and the reliability of our system, with the grid, to deliver it to your doorstep, to do whatever you are doing, will be made available. So nuclear is a complement to other sources, such that when we do our wind to the end, that we don't have any more reservoirs for wind or reservoirs for geothermal, and we still require energy to develop. We require to have some additional backload, so that when we do away with coal, if we have utilized all our coal, we shall be able to have additional reserves that we can use, and that's how nuclear is coming into the energy mix.
Mm-hmm. You've compared and mentioned other sources of power while speaking and trying to tell us why we should go nuclear. But I have this question, and this can go to you, Nduma. He mentioned that nuclear is reliable, it's some sort of a clean energy, and looking at other sources of energy or of power, we know of hydro, which comes from water. We know of geothermal and solar, which come from the natural resources that we have. Talk us through nuclear electricity. How do we come from a point where we are out there in a plant to a place where we see lights in the living room using, or rather relying on nuclear electricity go up? Talk us through the process of producing nuclear electricity.
Okay, thank you, Mudoka. Now, and thanks for the question also. I'd also like to point out that, as Harrison said, nuclear is also not subject to the vagaries of weather. It's also not subject to the political situations of the country where you're importing your energy from, like oil. Mm-hmm. When there is conflict in the Middle East, your oil prices go up. And then the other nice thing about nuclear is that plant life. From commissioning till decommissioning, it will last 80 years. So that's unlike any other plant that we have, and that's one of the reasons why it's favorable. Now to take us through how nuclear energy is generated, nuclear electricity is generated. So first of all, you must have your nuclear power plant, which has a component called the reactor vessel. Inside the reactor vessel, we have something called the fuel assembly, where we have nuclear fuel, which is basically uranium, enriched uranium. So this uranium is bombarded by a neutron. So you generate the first neutron that will bombard the nuclear fuel, the uranium, enriched uranium, to generate electricity. But again, electricity is not generated at that point. At that point, what we generate is heat, a heavier uranium atom, and more neutrons, fast neutrons that continue the chain reaction of bombarding the nuclear fuel to generate more heat and more neutrons that continue with the chain reaction. So after the first reaction, you generate heat, neutrons, fast neutrons, and uranium. So the heat is transferred again from the reactor vessel to the turbine. You know, basically all generators work. They have a conventional part that you drive a turbine that drives a generator that generates electricity. So this heat is used to drive a turbine. Once it drives a turbine, the turbine drives the generator, which eventually generates the electricity that you use in your homes and industries. So basically that's how a nuclear power plant works. Yeah.
Looking at us as a country, a journey that we are in as a country, the nuclear journey, I must say, looking at other countries, we are not alone in this journey. But when you look at us and other countries, especially in the continent, where would you rank us?
We have South Africa that is way ahead of everyone in Africa because they're already generating nuclear power. They have an installed capacity of over 1,800 megawatts of nuclear electricity in South Africa. So yeah, South Africa is way ahead of all of us. And then we have countries that are considering nuclear in the continent, and that includes Egypt. We have Ghana. We have Morocco. Morocco actually have already installed a research reactor. So they use the research reactor to do nuclear research. So yeah, we have Uganda considering it. Yeah, so we have a number of countries. So I'd basically call Kenya a fast follower. Mm-hmm. We are hot on South Africa's heels, and we hope to get there and become a leader in the industry probably in the future. Yeah.
But while we are going towards this route, other countries, in as much as you've mentioned South Africa, Egypt and Ghana, we also have other countries that are considering shutting down their reactor plants. But we as a country are in the process. We have put plans in motion to set up nuclear infrastructure. Do you think that that is the right move? And why the contradiction? Why do we see other countries going opposite ways, unlike us?
Okay, I'd like to point out the other countries that are considering shutting down by 2030. There are only four. Spain, Switzerland, Germany and Belgium. They are considering shutting down their nuclear reactors by 2030. Italy, Kazakhstan and one other country have already shut down. By 2020 they'd already shut down. So, but two of those countries, Kazakhstan and I've forgotten the other one, they are planning for new builds. So they are not getting out of nuclear. Okay, and in addition to that, there are countries that are also coming in. There are countries that are introducing nuclear, like the UAE. They've commissioned, was it last year? They've commissioned their plants last year. We also have Finland, although it has taken long, but they're also building new plants. And globally, we have a lot of nuclear power reactors operational. Okay, we have around 443 reactors in 30 countries. So the trend, despite the four who want to leave, and 2030 is 9 years from now. Again, it was a political decision, not really technical, so they might change. Politics are never fairly consistent, so we're not really sure, but we cannot base the argument on the four, yet there are others coming in, and the four might also change their minds going to the future. So yeah, and again, our assessment is not pegged on what other countries are doing, but we are looking at the feasibility and viability of the national program. And we can rest assured that we have a capable team looking into that, and so far the direction is for and not against. Yeah.
I'd like to shift the focus of this conversation to you three gentlemen here. You spend most of your time in the university setting. You interact with students who actually would like to push the nuclear agenda forward. But then I understand maybe you have faced this particular question from your students. Why do you keep on teaching this particular subject, yet we see countries shut down their power plants? What will be your individual takes?
Yeah, maybe I can just start by talking about the atom and what we use it for. Because for us, at our institute, the Institute of Nuclear Science, this is not the first time that we are interacting with the radiation. I think the conversation about nuclear energy, it started the other day, but we have actually been dealing with the nuclear energy for a long time. And I think before I go there, just to bring you into the context about the strength of the atom. I think like 3 years ago, we put a satellite in space here at the University of Nairobi. And the reason I'm mentioning that is that, have you ever asked yourself how those satellites and spacecrafts are powered? We have missions. I think the other day we had about a landing in Mars, and it has been happening in Mars. But the question that people don't ask themselves is, how are those things powered? And so that to bring into context the real power of the atom is that we have spacecrafts which have been in space for the past 30, 40 years. They have never come back. And they are still sending images to this day. How are those things being powered? Now, it is the atom. Most of them, they are powered by plutonium. I think two sources. You have one source is the solar. Now, to power satellites, solar can only power satellites when you are just near the orbit, all right, where you can access the sun. But for you to be able to go out of space, into those cold spaces, you need power for your instruments. First of all, it is very cold up there, so you need something to hit your equipments. The next, those equipments, those scientific equipments there, they need to be powered. We have seen images, and I'm sure most of our viewers have seen images about Mars, about Jupiter, about Saturn. Those images were only possible because we had only one source of energy that could be used, and that is a nuclear, an atom, basically plutonium. And what happens is that all this radioactivity and this decays, it generates heat, and this heat now is converted to electricity, and which is now also being able to power now those instruments. So that is just to bring into context the idea of the strength of an atom. Now here in the country, we have been using nuclear for a long time for different purposes. And I think I'll just mention a few areas that we have been using it, so that now when we bring nuclear energy is just an additional use of the atom. For the past 40 years, we have been interacting with I think if you go to our labs, we have things, you talk about uranium, about thorium, and all these radioactive materials. Those are not new, and we have been using them. If you go to our health centers, we have the hospitals, they are doing radiotherapy, they are doing diagnostics. We are using things like cobalt. Cobalt is a product from a nuclear power plant, and when it is decayed, you have to take it back to the nuclear power plant to recharge it and bring it to our hospitals. We have technetium generators. Technetium generators, if you go to these hospitals, they are using it, and that one has a very low decay period, which means every few weeks you have to send it to a nuclear power plant. And if you look at the economic cost of it, the cost of exporting it to a country that has nuclear power plant to refill it for us and bring it up here, so that is another factor of cost. If you go to the industry, I think people in industry, you must have done even radiography. The same way you do radiography in a hospital, also in industry we do radiography for quality controls. Part of the sources that we use for those works are, we have iridium, we have cobalt. All these are byproducts or products which are produced from a nuclear power plant. And so for us to continue teaching about nuclear, it's not a question. We will always be teaching. We have been teaching and we will continue teaching because nuclear is part and parcel of our life. But I think as we go on, I'll be giving you more examples about the kind of uses that we have been using and why we'll continue using the nuclear.
Dr. Wekesa and Mr. Kairu, Harrison and Nduma here insists that the nuclear dream is realizable in terms of it being a key component in our energy mix and especially in the production of electricity here in the country. But we both know that plan mainly hinges on a very robust manpower. That manpower won't come anywhere else but within these four corners of the lecture hall. Do you see us as a country being able to self-generate our own manpower and not rely other countries from the outside?
If we look at it as a nuclear as an alternative energy source being a baseload, even to some of our heavy commercial sector, then we actually need to look at the issues of workforce, the issues of capacity building. And when we talk about capacity building at the university level, I think what we are focused on now, we are looking at modeling, the nuclear modeling aspects of it. There are aspects like nuclear economy. There are aspects like nuclear law. Then the major part is the waste management, especially the disposal aspect. And I think that's where the agency and maybe the university and maybe the industries, the players, need to come together, because the disposal is not only on the issue or the challenge on nuclear, maybe technology. It is also a challenge in other alternative energy sources.
For us to move forward, we definitely need a qualified workforce. Let's talk about qualified workforce. What are these qualifications, let's say, for one to work at a nuclear power plant, perhaps?
In a nuclear reactor, so we expect quite a big number of people working within the reactor itself. But probably, we'll have a team which just require training in radiation safety. Those who are not directly involved in sort of operation of the nuclear reactor. But for the main team that will be working, probably will need to be trained in nuclear science, nuclear technology, and probably nuclear engineering. As a country, currently, the Institute of Nuclear Science have been able to meet the needs of peaceful nuclear applications that have been in operation in the country. It's just a question of sort of expanding our scope and partnering, with the other institutions out there, so that we are able to train manpower, local manpower here. Yeah. So I believe moving forward, it should not be a big problem for us to expand into, being able to train people here locally. Thank you.
Harrison and Nduma, I'd like to ask a question that touches on the three, but I not want them to, let's say, blow their own trumpets in this case. But this question touches on local universities. And I like to assume that you've been out there, you've seen how things are done by other countries in terms of teaching and in terms of equipping its young, fresh blood, matters nuclear science. Do you think where we are, we have the required infrastructure in our local universities to propel the nuclear dream? And do you feel like you, as the Nuclear Power and Energy Agency, do you feel like you have a role to play in ensuring that this infrastructure is at a level that other countries are at? Harrison, maybe we can start with you.
I think we have categorized the people that we need into a nuclear power program. They are basically like three. From my policy point of view, I call them, we need people who are nuclear people. Those people are trained in nuclear science, nuclear engineering, and everything nuclear. And we need people who we call, they are nuclearized. For instance, we have a lot of engineers in this country. Mechanical engineers, chemical engineers, water engineers. They are all qualified engineers and they are qualified to work in a nuclear power plant. What we need to do with them is to nuclearize them. Take the electrical engineering degree and put some aspects of nuclear. So you are electrical engineer. What you're going to do in a nuclear power plant is still electrical engineering. But now we just put another aspect of nuclear. And then there is another significant group of people who we call, they just need to be nuclear aware. That you are a plumber, but when you go into a nuclear power plant and nuclear environment, you need to be aware of the things that we call about nuclear safety, security, and safeguards. So you come with your plumbing qualifications, and we need you to be aware of the environment of nuclear. So we are not going to need tens, thousands of nuclear engineers to operate one nuclear power plant. And we have done some studies, have done some modelings, and my colleague will come into that because he's the one leading that, to show what is available in our local universities, in our local academia. When we enroll, let's say, 1 million kids in grade 1, or whatever they are calling it nowadays, I don't know, up to how many of those drop around, how many of those go to high school, and how many of those are going to into universities. And what is the competition between the industries? That if you churn, for example, 10,000 engineers in a year, where do they actually go? If you do that kind of an analysis, you'll find you have even more people than you can accommodate. So what we need to do is to put our policies right, to actually the strategies we have made, or that we are making, and which I want my colleague to come in and weigh on that.
So what we've decided to do is assist, which is also part of NIPEA's mandate, to assist in capacity building. We've decided to do that. We've not really decided, we've mandated to do that. And what we are doing right now is we have been in collaboration with the University of Nairobi, the institute, where we offered scholarships to some of them, to some of the students there. And some of them have graduated, some of them are completing. We've also been in collaboration with the Kenyatta University, also together with the International Atomic Energy Agency. And what we've done with them is, and also the Moroccan government, sorry. And what we've done with them is, as I said earlier, Morocco has, they have a research reactor. They just commissioned a research reactor a few years ago. So there's a program called the Internet Research Lab, where you can learn remotely, where students in Kenya can actually take part in the Moroccan classes in the research reactor. So we've partnered with the Kenyatta University with that, and with that we hope to train more people, give them, I won't call it hands-on experience, but it's near hands-on, because they are seeing in real time, and they're also asking questions and getting to learn more about it.
How vibrant is our partnership with other countries?
We are doing well in terms of our partnerships. Again, as I said earlier, our partnerships with, we're partnering with the International Atomic Energy Agency, the IAEA, which is a body formed by member states. So that counts for a lot of countries. And we take advantage of that by tapping in the IAEA's network pool, because they have a network of countries that operate the nuclear power plants, and we take advantage of that. And out of that, actually, some of the capacity building initiatives that I talked about and Harrison has talked about are derived from our relationship with the International Atomic Energy Agency. We also have partnerships with, we had one with France, we've had some with Korea, Russia, where we mainly at this stage are for capacity building. Train as many people as we can. Some of them will come, some of them will remain where they are, but our objective is to build national capacity. Yeah.
To our dons here, just before we move on to another question, how vibrant, of course, are your partnerships with other universities? Are you exchanging notes? Have you decided to go it alone now?
Maybe, Mutoka, before maybe I just answer that question, my colleagues from NUPEA have talked of course, there are a number of engineers locally here. But I want to be sincere on this subject, especially on the kind of personnel that actually the universities are churning out. I think the agency, maybe you need to maybe change the strategy, because ask yourself back, even as you step out of this building, and even the same building, I know we have civil engineers from UN, from all parts of maybe public universities in Kenya. But ask yourself, why do we have the Chinese? Even when you look at the matchstick, sometimes you have a symbol as that, even the cooking sticks. You will see a label made in China. So that's a question we actually need to think and maybe see whether, as an agency, it's not just about the numbers. It's maybe about how competent, as much as you take them with their papers. But there is a gap, especially when it comes to actually the competency of actually some of the personnel we have. I'm not saying all. Then back to your question, I think is very important, and I think the agency, we thank you for the partnerships, which I'm sure even we have been the beneficiary. There's need for exposure, especially to our students, even at master's level. Thanks to the institute here at UN on nuclear, I'm assuming that you maybe have some equipment, but in most of our universities, what we are having are mostly models. So when somebody comes out of the university and he has done, some courses on nuclear, he has a picture of a model. But now when it comes to the actual nuclear plant, there is no exposure. And that's why maybe for Multimedia University, what we are doing is we partner with the national universities and just give a chance, an opportunity to our students just to have exposure, especially to the nuclear plants which are there. And I think for the agency, I think we can actually move together. We don't actually need to go to those engineers. Even at TVET level, I think after this topic is going to even go down there. Even at high school level, you can actually identify these talents and nurture them, and even give them an opportunity like innovation, if they are having their science and engineering fairs, you can pitch there and actually try to mentor these students up to from that level than when you just wait for a mechanical engineer and then undergoing the system that we have here, whereby we have that gap, especially in terms of exposure, what is happening in the industry. So I think once you give that synergy and you call us like the way you have called us on board, so that we are able to know actually what is happening. Thank you.
To John and Wilson, Nduma mentioned, or rather spoke to us, the entire process of generating power through nuclear science, and that is a plant that must rely on a nuclear power plant. And as a country, top officials at NUPEA spoke of hope that a plant might come by the year 2026 or thereabout. And this is a plant that, as he mentioned, sophisticated, complicated, and which might require a country with financial muscle. From where you sit, do you think that we have what it needs financially to set up one?
Maybe before I answer that, allow me to just weigh in a little bit about on the manpower. I think one thing that I need to mention is that as an Institute of Nuclear Science, we have actually been exporting nuclear experts. I have to mention that, for example, the only country in Africa with a nuclear power plant is South Africa, and one of the deputy directors is actually one of our own. And I can also mention a few other cases in Canada and also the US, where our people have been actually working on nuclear power plants and regulating them. So I am very confident that in that case we will be able to go nuclear and to develop the necessary manpower. Now, in terms of financing, I think Kenya, especially since the new regime came, when we brought in the Big Four agenda, we have done mega projects. The kind of projects that are going on right now are things that nobody expected that we could finance, running into a tune of billions of shillings. So for the project of nuclear power, there are different options that will be considered. And if you look at the energy, some of our generators have actually been based on you build, own, operate, and then you transfer. And that's one of the models that I believe will be considered in this case, which means an investor comes in, he builds, he operates, and at some point he transfers with the government as the security and the overall owner. Yes.
Wilson, just before you speak about that, I'd like to tie your answer to this question. This power plant comes with some level of seriousness, and actually safety is a major concern headed there. How safe do you think we can be as a country? And this is a question now, the floor is open to any of us here. Are we really safe if we decide this is the direction we are taking? We have decided it is the direction. How safe are Kenyans going to be?
Yeah, thank you. I think it is a very important question because I think some of the countries that are pulling out or thinking of shutting down their reactors is issues to do with safety. So it's a very important point of discussion. But I think if you look at what we have in the market, the current technology, we have a lot of safety features integrated into the designs of these reactors. So, which means we have a lot of controls that will ensure that in case of probably of failure, it will not lead to catastrophe or the waste being emitted into the environment. In addition to that, you find that the nuclear industry is a highly regulated industry. So you have the International Atomic Energy Agency, and it sort of provide a lot of guidance and assistance to countries. And I think there is also a lot of monitoring whether you are putting these sources or the fuel into the right use, because most of these sources can be diverted, and I think that's where most of the fear of nuclear come from. So it can be an issue of safety and security, where these sources are diverted to be used for probably, for example, a nuclear weapon, which can be catastrophic. So in a way, it's usually highly regulated and monitored. So we can guarantee the safety of our citizens. And I think we need to sort of trust in our people. I think one of the major problems we've had in these countries, we don't have faith in our young people. So they'll go out there, but still you feel that they are not able to do enough. So, but I believe as a country, we are ready for this technology, and with the safety features in most of the current generation in nuclear reactors, we should not have much to worry about accident. I think the probability of dying maybe in an air crash would be way much higher than maybe dying as a result of a nuclear accident in the country. Yes, thank you.
Gentlemen, I know you all have individual answers to this. We seem to be quite pressed for time. So I'd like to ask this final question, and then from there we'll have closing remarks from you. He talked of safety, but there's another pertinent issue that comes with it, and that is waste management, because of course there are emissions. But how certain are we that waste management won't be difficult for a country that actually is unable to manage its domestic waste in the first place? Maybe Nduma, then we can go around with closing remarks for a minute or less.
So I do it with my closing remarks. Okay, thank you for the question. First of all, as we talk about waste management, we need to consider the waste being generated first of all. And for a nuclear power plant, this might come as a shocker to most of our viewers, but a nuclear power plant, the amount of waste being generated by a nuclear power plant is, you can store all of it on the site. Okay, you can store most of it on the site. Number two, waste is usually managed on time. Okay, so once you, okay, I talked about the process of electricity generation from a nuclear reactor. So most of the nuclear reactors have a refueling period of 18 months. That's 1.5 years. So after the 1.5 years, you take out your fuel, and then once you take out your fuel, you put it in something called a spent fuel pool, where it decays further, and basically you're reducing the radioactivity of that fuel. And after that, you're going to take that fuel and put it in a fuel cask. A cask is just short form of a casket, where you store the fuel safely. And remember, as you're doing all this, there are people who are working in that plant. So they're still safe. Anyone who works there is safe. And as Kairu mentioned, the International Atomic Energy Agency is not a regulator. But what it does is it does safeguards monitoring, if I may call it, to ensure that main reason is to ensure that there is zero, non-proliferation, no proliferation of the fuel, because that will mean that you're probably going to use it for harmful, non-peaceful purposes. So that's how you operate it. But as we are moving forward, we are currently developing a plan on radioactive waste management. I do not want to speak about it right now, but I can guarantee everyone that it will be a good plan. Other countries have done well. Sweden is doing exceptionally well. Countries like the US still do not have a final waste management plan. They're still waiting, but we are not waiting till we decommission our plants for us to think about waste management. We are actively thinking about our waste management plan. Yes, and we are doing a robust plan for that.
Okay. You consumed your closing remarks with time. Let me give each some 10 seconds. So
it's okay. It's okay. It's okay.
Maybe you have an opinion?
Yeah. Okay. Maybe as we conclude, I think my colleague here talked about African Agenda 2063. And this is sort of a blueprint. We want to Africa want to become a powerhouse a global powerhouse. And moving into the future, and the future is now, it should be in nuclear science. So we are ready, and we cannot move into the future without nuclear technology and nuclear power generation. Thank you.
John?
From the Institute of Nuclear Science, we have a program on nuclear science in masters. We are converting all physicists, chemists, engineers, geologists, and all those kind of people to do a masters in nuclear science. And we have been doing this for a long time. And whether there is nuclear power or no nuclear power, we'll continue teaching, because the applications for nuclear techniques has been with us, and they will continue to be with us as we go forward. Thank you.
Doctor?
Toka, I think waste management disposal is not only a big challenge to nuclear plants, but is also a big challenge even to the solar plants and other sources of energy. So that should not be actually an issue that should stop us thinking or expanding our energy mix. But what we should do is maybe invest in research and development, especially on these disposal techniques, and also open ways for innovation, put some more budget. Our youths are innovative, and work with the agency, because we are going to be like the implementers, and maybe go ahead and engage even the industry so that we move this debate to even the people, the communities down there. Thank you.
If I have to weigh on the radioactive waste, I like talking about money. Maybe it's where I come from. One of the plans that we can put in to do with waste, you know, there are countries out there who are doing fuel fabrication, they are doing processing, they are doing such kind of stuff. So when you sign a contract for the purchase of fuel or for the purchase of reactor, you can tie in that you bring us the fresh fuel, we are going to use it and cool it for some time like he said, and then after that you're going to take it and go do your processing elsewhere. That's still one of ways that you can look into. As my closing remarks, I would like to say, I like referring to development plans. Statistics are showing us that over 250 million people who live in Africa do not have access to electricity. And population statistics, they're also telling us like by the year 2050, population in Africa is going to double. That for every child that is being born worldwide, it is going to be born, the 50% chance is going to be born in Africa. We have a challenge in our hands that these young people who are coming up, who form a huge percentage of our population, they require to live a good life. They are the people who are going to move into cities. And so we need to put our plans, we need to put our strategies right to be able to take this thing into the future. So this project, this nuclear power thing, is not an UPEA project, it's a government project, it's a national project. It belongs to you, it belongs to all of us. Be free to make your comments and be free to provide input wherever it is necessary. Thank you.
Thank you. Gentlemen and our viewer, I must say this conversation has been riveting enough. I know we might have wanted to extend this conversation, but of course it's been totally informative. Special thanks go first to you, the debaters. I must say you represented your teams very well. I must also applaud the audience for being here and making this worthwhile. This conversation, of course, does not end here. It goes on tonight and for the days to come on social media. I'd urge each one of us to be a part of it, to be a part of shaping our future as a nation. And to our viewer, remember, this debate is part of a 10-episode series by TV47 on matters nuclear sector. There is a lot more on the series, and I'd bet you will not want to miss out on our next episode here on TV47. Be sure to catch us then. That is it for now. My name is David Mudhoka. On behalf of the team that made this production a success, thank you for watching. Do enjoy the rest of our viewing.